Question 13 deals with the test of proportions. So they start out by telling us a random sample of 1,800 observations from a binomial population produced X equals 828 successes. You wish to show that the population P differs from 0.5. So first off, if what we're wishing to show is that the population P differs from 0.5, it's not telling us we think it's bigger than 0.5 or we think it's less than 0.5. For that reason, the alternative hypothesis here, what we're trying to prove, is P is not equal to 0.5. Always the null hypothesis is the same population value P, just with an equal sign, same value we're comparing it to, 0.5. So when we go to find the test statistic and the rejection region, our test statistic needs to be based off of the z-score for a binomial situation. So remember, here we're going to first calculate p hat as x over n. Then to find the z-score, we're going to take that p hat we calculated, subtract the p under the null, and divide it by the square root of p under the null, 1 minus p under the null, over n. In this case, x over n is going to be 828 divided by 1,800. When I put that into my calculator, I get 828 divided by 1,800 equals 0.46. So my p hat is 0.46. That means my z-score is 0.46 minus 0.5 over the root of 0.5, 1 minus 0.5 divided by 1,800. When I put that into my calculator, 0.46 minus 0.5 and parentheses divided by parentheses root parentheses 0.5 and parentheses new parentheses 1 minus 0.5 and parentheses divided by 1,800. I get all this to give me a z-score of negative 3.39. So I'm going to put that in down here where it asks for my test statistic. Now that I have my test statistic, I need to determine whether this falls in the region of rejection or not. So in this case, we have a not equal to alternative, and we want our alpha to be based on something that I haven't had written up here. Let me double check what it was supposed to be in the system. So here, provide an alpha equals 0.05 rejection region. If we know that alpha equals 0.05, then graphically what we really know is that there's 0.025 in this side, 0.025 in this side. Because it was a not equal to test, we have to account for both of these. If I were to look up in the center of the table, 0.0250, it would point me to negative 1.96. On the other side, I'd also get positive 1.96. Again, hopefully you don't have to look these up as you're doing the test because you have all the possibilities right in front of you copied down from slide 10 in the last presentation for the class. So for my positive region, z is greater than, it would be 1.96. For my negative region, z is less than, it would be negative 1.96. This negative 3.39 falls well into this shaded region. For that reason, I reject the null at the 5% level.